Welcome back to the Cave Science, and we're going to do a brief look at electronegativity here. Electronegativity is a qualitative measure of how much an atom attracts an electron in a chemical bond. This is a unitless number, and you can get electronegativity values from many tables. You can go ahead and Google it. And most of these electronegativities, Linus Pauling is really given a lot of credit for this. Again, it's a unitless number, and it's just given a relative polarity, if you will, between different types of chemical bonds. And to find electronegativity, it's the absolute value of the first element minus the second element. And again, it's an absolute value number here. And so we're really looking at the bond type. So if we have a pure covalent bond, the electronegativities are going to be less than 0.4. If the electronegativity is 0, the difference in it, those are typically going to be your diatomic elements. If it's a polar covalent, the electronegativity values are 0.4 to 1.8, and if it's ionic bond, you're looking at something greater than 1.8. These are not hard and fast. In fact, if you look at different sources, you'll see maybe a little bit different numbers given, but these will give you a general range here for determining if you have a non-polar covalent bond, a polar covalent bond, or ionic. And let's go ahead and take a look at a couple here. So here we got an HH bond, and if we take our difference in electronegativities, hydrogen is 2.1 minus 2.1 is 0. That's a non-polar covalent. Quite often you'll see it referred to as the pure covalent, and this will happen when you have your diatomic elements. Another example here is the H and the Cl bond. So if you look at the difference in electronegativities, you'll see that it's 0.9, and that falls into the realm of the polar covalent bonds. The last one we have is sodium and chlorine. And if you look there, you have 0.9 minus 3 is 2.1, and it is considered an ionic bond. So these are really pretty easy to figure out. And the table above, the values above, gives you a little bit of a rough idea where these values lie for a pure covalent or nonpolar, a polar covalent, and an ionic bond. So I hope this helps, and again, you can find these values on any electronegativity table that you can Google. So until next time.